Hi, today we're looking at Functional Skills Maths Level 2 and this is exam board NOCN. Now I don't know too much about these guys. If anyone out there is using them, be interested to know what you think. So we're going to start off with the non-calculator section. Okay, so question 1. We've got 2,456 plus, and then it's a negative 563. Well, we've got the plus and the minus here, so the minus is going to win, so we can kind of replace all of that with just a minus. So basically what they're saying is 2,456 take away 563. Okay, so start off with the units. 6 take away 3 leaves us with 3. 5 take away 6. Well, 6 is more than 5, so we can't take it away. So instead, we're going to take 1 from the 4. So we'll reduce that to 3 and we give 1 across. And now we've got 15. So 15 take away 6. It's going to leave us with 9. We've now got 3 take away 5. Well, again, 5 is bigger than 3. So we're going to take 1 from here, so reduce that to 1. Put 1 in front to make it 13. So we've got 13 take away 5, which is 8. We've got 1 take away nothing, which leaves us with 1. So our answer is just going to be 1,893. Okay. Question 2. Right, so we've got some coordinates here, or we've got a XY coordinates with some points marked on there. Okay, and the question is, what are the coordinates of C? Tick the correct box. Okay, well, so we actually don't need to see all of this. We just are interested in C, which is here. So this one. So we want the X coordinate first. So we're going to look up. So the X coordinate is 5. And then the Y coordinate, look across here, is going to be -4. Right, so now we can look at all our options, see if we've got any that match up with 5 minus 4. Well, it's this second one here. So we don't care what the others are. This matches what we found. Line this up, and we've got question 3. Find the mode of this data. Well, the mode, that's one of our averages, and that's the one that occurs most often. Now, before we start looking at that, you might notice that we've got some of these measurements or weights in grams and some are in kilograms. So what we want to do is get them all the same. Now, you could change your grams to kilograms or kilograms to grams. What I'm going to do is we've got 1 gram. We've only got 2 in grams, so I think it's going to be easier if I convert the grams into kilograms than the other way round. Now, I know that there are 1,000 grams in 1 kilogram. So if we're going from grams to kilograms, we're essentially going to be moving our invisible sort of decimal point at the end of the number 3 places to the left. So 1, 2, 3. So this is going to be equal to 36.4 kilograms. So I'll show that again with the grams. So if we've got, with this one here, if we've got 4,300 grams, if we know 1,000 grams is a kilogram, well, we're going to have 4 kilograms and then 3, which is going to come after the decimal point. So if we do it the same as the other one, we start at the end. We've got 3 zeros here, so we're going to go 1, 2, 3. So we're going to have 4.3 kilograms. Right, so we want to find the mode. We want to find which of these numbers occurs the most. So, in fact, you could just look at them, but it's not very clear at the moment. So what I'm going to do is I'm going to put them in order. So which is the smallest one? This looks the smallest. Let's put a 1 there. So 22. Oh no, this is going to be the smallest, isn't it? So this is going to be the smallest, 4.3 kilograms. Then we've got 75, 51. Then it's going to be this one here, the 22.1. Then we've got 36.4 kilograms and another 36.4. What's the next smallest? Then we've got 54, 56, 51 be the next smallest. Then 54, then 56, and so the biggest is going to be this 75. So I can now write them out in order, but actually by going through that, I think we saw that we had two of these values which were both 36.4 and none of the other values repeated. So the mode is going to be 36.4 kilograms. Okay, question 4. Tim has decided to landscape his garden. His garden is a rectangle 11.5 metres by 15.75 metres. He wants to have 2/3 grass and the rest as a patio. He also wants a shed, and the shed's 3.5 metres by 2.25 metres to be placed in any corner of the patio. Draw a scale drawing on the graph paper below. Label the drawing clearly. Okay, so we're going to have, so all of this is going to have to go on our grid down here. The first thing I want to draw is our garden, so the overall sort of size that we've got. We know it's 11.5 metres by 15.75 metres. So we're going to think how we can put this on here, because they haven't told us what scale to use. Now we could do 1 metre on here is 1 square on here. But if I move this up, you'll see it's quite a big grid. If we did do that, then 11.5 metres, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11.5. So it would go sort of into here. And 15.75, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That would take us down to here. So it wouldn't be that big. Okay, so I'm thinking we're going to need a different scale. Well, maybe if we say instead of 1 centimetre is 1 metre, what about if we've got 2 squares for each metre? So if we had that, what we're saying, so that would mean that everything would be twice as big. So we're going to say that 2, let's bring this down here, squares equals 1 metre. Well, if we do that, that means instead of 11.5, we're going to want 2 lots of this. So we want to double this, and it'll tell us how many squares we need on the grid. So let's try that. So if we're doing 11.5 times 2, well, to start with, we can ignore the decimal point. We just treat it as 115 times 2. So 2 times 5 is 0. 2 times 5 is 10, so we put the 0, carry the 1. 2 times 1 is 2, add the 1 is 3. 2 times 1 is 2. And then we need to put the decimal point back in. Well, that was just 1 decimal place, so we put that in there. So this 11.5 metres is going to be 23 squares. And we're going to need to double this number as well. So 1575, and we're going to multiply that by 2. So hopefully this makes sense why we're doing it by 2, because we're saying we're going to need 2 squares for every metre. So I'm ignoring the decimal place to start with. 2 times 5 is 10, 0, carry the 1. 2 times 7 is 14, add the 1 is 15, so 5, carry the 1. 2 times 5 is 10, add the 1 is 11. 2 times 1 is 2, add the 1 is 3. This time we had 2 decimal places, so we're going to put the decimal point in there. So it's going to be 23 squares by 31.5 squares. So that's going to be the first thing that we're going to mark out on here. So which way should we do? Have we got enough to go across. We need 31.5 squares, so we want 32. So 1, 2, 3, 4, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 29, 30, 31, 31 and a half. So we're going to go halfway into this one. So that's fine. I'm just marking that there. And I'm going to need my ruler in a moment. And how many squares are we going down? 23 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to disappear off the page for a bit. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so you're going to have to trust me down here. I've got 23, so I'm going to draw my line across. And I'm doing this one until it meets up with the line. Well, look, if I start drawing this one up, and then pull it down, and you'll see that we can join it up to here. Okay, so we can mark on here that this is 15.75 meters that way, and we've got 11.5 meters going down this way. Right, so we've got the garden bit on there to start with. Now we've got to start thinking about the split between the grass and the patio. He wants to have 2/3 grass and the rest as patio. Okay, so 2/3. Well, I'm thinking, let's think about if we can split this rectangle into sort of 3 strips. So then we can find what 2 of them are and we can cut it off that way. So if we want to split it into thirds, so split it into 3, we're really going to need to divide the 15.75 by 3. Okay. So first of all, we say, how many times does 3 go into 1? Well, it doesn't go into 1. So what about 3 into 15? Well, 3, 6, 9, 12, 15. That's 5 times. And we can put a decimal point. How many times does 3 go into 7? Well, 3, 6. That's twice. And then 1 more will take it up to 7, so we carry the 1. How many times does 3 go into 15? Well, we saw that at the beginning, that was 5. So 5.25 squares would be 1/3 of the garden. Okay, so let's see. Sorry, not 5.25 squares. That's 5.25 meters. Okay, actually what I could have done, which might have been easier, was divide the 3 into the 31.5. But I've done it this way. So we've done it in meters. Now we want to turn it into squares. So to turn it into squares, we're going to need to double the 5.25. Yeah, slightly long way round. But I'll show you the other way in a moment. So 2 times 5 is 10. 2 times 2 is 4. Add the 1 is 5. 2 times 5 is 10. Put the decimal point in 2 places. So we're going to get 10.50 squares. So yeah, what I should have done was, because I know we're working with squares here, I should have just said, well, let's divide our 3 into the 31.5. So 3 into 3 goes once, 3 into 1 doesn't go, but carry the 1. 3 into 15, we saw, goes 5 times. So you'd still end up with the 10.5 squares. It's just maybe a bit quicker if I'd gone straight for that method. Okay, so we want 10.5 squares for our patio, because that's going to be 1/3. So if 2/3 are grass, that means 1/3 is patio. Now we've got half a square here, so I'm going to start counting from this way. So that's going to be my half a square, and then we want another 10 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. draw a line down like that. So that means that this is going to be my patio. This big area is the grass. Okay, so we're slowly getting there. We've got our rectangle, we've got the garden marked out, we've got how much is grass, we've got how much is patio. The final bit they want is, he wants a shed 3.5 metres by 2.25 metres. And it needs to be placed in any corner of the patio. Well, as we saw from our scale, we've got 2 squares of 1 metre, so we're going to want to double all of these numbers. So 2 times 5 is 10, carry the 1. 2 times 3 is 6, add the 1 is 7. And then we put our decimal point in. So we're going to have 7 squares. Now we need to double this one. 2 times 5 is 10. 2 times 2 is 4, add 1 is 5. And 2 times 2 is 4. And we had 2 decimal places, so we're going to put the decimal point in 2 there. So we've got 7 by 4.5 squares for the shed. And all they've said is place in any corner of the patio. Okay, so where shall we put this? Well, we've got a half a square, so I'm going to put it up in this corner. 4.5 squares, so this is my half, so I'm going 1, 2, 3, 4. So I'm going to start there. And then we've got 7 squares in the other direction. So 1, 2, 3, 4, 5, 6, 7. So we can mark a corner there. So that's going to be our shed. Okay. They can be quite tricky, these questions, because we've got quite a lot going on. We've got the conversion bit, we've got to work out what scale to use to start with. We've got a bit of multiplying, bit of dividing for 4 marks. So, yeah, can be tricky, but a nice way to get the marks. Okay. Question 5. So we've got 5/6 plus 13 quarters, or 13 over 4 equals. So we've got to work this out. So what I'm going to do is try and go for a common denominator. So we can't add these because the denominators aren't the same. So we've got to find out, well, what denominator can we use that both 6 and 4 go into? Okay, so in other words, a multiple of both 6 and 4. Well, I know that 2 6s are 12 and 3 4s are 12. So I'm going to write this all over 12. Okay, so we want basically a number that 6 and 4 goes into. If you aren't sure, if you couldn't find 12, you can say, well, 6 times 4. That'll give you 24. So it's a bigger number, but it will still work. But as I say, because I know that 2 6s are 12 and 3 4s are 12, this is going to work fine. Now, to get from 6 to 12, we're doubling it. So we have to do the same to the top number. So we're going to double the 5, which is going to give us 10. We've still got a plus. Now, from the 13 quarters, well, to get from 4 to 12, we multiply by 3. So we're going to have to do the same with the 13. We're going to times it by 3. So let's do this over here. 13 times 3. Well, 3 3s are 9. 1 times 3 is 3. So we're going to get 39 up here. Okay, so we've turned it from 5/6 into 10 twelfths, and from 13 quarters into 39 twelfths. But because the denominator is the same, I can just write it once underneath. If you want to write them as 2 separate fractions with the plus in between, that's not a problem. Okay, But now we've got the denominator the same at the bottom, we can just add the top. So let's bring this down here. So 10 plus 39, well, I'm just going to add 1 to the 10s, which is going to be 49 over 12. Now, they haven't asked you to simplify or write it as a mixed number, but we can do that anyway. So we can say, well, how many times does 12 go into 49? Well, 12, 24, 36, 48. That would be 4 times. And from 48 to 49, it's going to be 1/12. So you can give either answer. Either one would be fine. Question 6. Alan is buying a house. It costs £1 million. He has a deposit of £378,500. The remaining amount he will borrow from the bank. How much will Alan borrow from the bank? So basically they want the difference between £1 million and 378,500. So if we want the difference, we're going to do some subtraction. So 1 million, 6 zeros, and we're going to subtract 378,500. Actually, let's use my ruler to do a nice straight line here and keep it all tidy. So 0 take away 0, nice and easy. Same again. 0 take away 5, well, we can't take 5 away from 0. So what we're going to have to do is get 1 from this 0. Now, we're going to keep going back because we can't take from 0, we can't take from 0. So we're going to have to take from this 0, which is going to reduce it down to nothing. But we're going to make this 10. But we're going to end up keep doing this because we still need to get 1 passed down the line. So that's going to end up being 9. And that one's made a 10. Reduce that down to a 9 and give the 1 over here. We still need to go 1 more time because it's here that we need the extra 1. So reduce this down to a 9 and we pass the 1 over here. So now we can say 10 take away 5 leaves us with 5. 9 take away 8 is 1. 9 take away 7 is 2. And 9 take away 3 is 6. So we end up with £621,500. Question 7. Calculate the area of a triangle where height equals 15 centimetres and base equals 7 centimetres. Okay, area of a triangle. Well, we need to know our area of a triangle formula. So, area of a triangle, and that is equal, you need to know this one really, is a half times the base times the height. Or if you can't remember, you can think, well, if I had a rectangle, I know that with a rectangle, the area is the length times the width. Well, if you think, if I've got a triangle, actually let's do it this way. Well, really a triangle is just half of a rectangle. So in other words, it's half times the length times the width. The only thing where it's a bit different is that with a triangle, instead of length and width, we tend to talk about base and height. But that can help you to remember. Okay, so we've got a half, the base is 7, and the height is 15. Okay, now, because we're still in the non-calculator section, we've got to think, well, what's going to be easiest? What's the nicest way to do this multiplication, because we can do them in any order. We can do half of the 7 or half of the 15 or 7 times 15. Now, when we do a half, because we've got odd numbers, we're going to end up with a decimal. So what I'm going to do is I'm going to multiply the whole numbers first. So I'm going to do my 15 times 7. So 5 times 7, 7, 14, 21, 28, 35. So 5 carry the 3. And 1 times 7 is 7, add the 3 is 10. Okay, so in other words, we now want a half times 105. Well, a half times 105, that's the same as 105 divided by 2. So let's work this one out. 2 into 1 doesn't go. 2 into 10, 2, 4, 6, 8, 10. That's 5 times. And 2 into 5, well, we've got 2, 4. That's twice. And 1 left over. Now, I don't want to have a remainder. I want to get a nice, tidy answer with decimals. So what I'm going to say is we've got 105.0. That means that my remainder I can now put in front of the 0. Put a decimal point there. So now we can say, well, how many times does 2 go into 10? 2, 4, 6, 8, 10. So that's 5 times. So we've actually got our answer of 52.5 centimetres. And because it's area, it's going to be centimetres squared. Okay, question 8. What is the probability of picking a blue ball from a box with 16 green, 4 purple and 5 blue? Write your answer as a percentage to 2 decimal places. Right, well, we want to know how many we've got all together. So we've got 16 green, 4 purple and 5 blue. So 6 and 4 is 10, plus 5 is 15. 1 plus the carried 1 is 25. So we've got 25 balls in total. Right, we want picking a blue ball. Now 5 were blue. So we're going to have, let's see over here, blue is going to be 5 out of 25. They want the answer as a percentage to 2 decimal places. So if we're doing it as a percentage, well, what we really need to do to turn it into a percentage is you multiply that by 100. Now, if we do this, well, we've got 5, well, actually different ways of doing it. What's going to be the best way? We could simplify this first, actually. Let's simplify the fraction. Because 5 goes into 5 and 25. 5 goes into 5 once. And 5 goes into 25. 5, 10, 15, 20, 25. So 5 times. So this is the same as a fifth times 100. Now, if we think about that, then we're going to have, well, we've got 1 divided by 5 times 100. We can do the 1 times 100 first, which is going to give us 100. And then it's divided by the 5. So 100 divided by 5. 5 into 1 doesn't go. 5 into 10 goes twice. And 5 into 0 goes 0 times. So we've got 20%. Now it does say write your answer as a percentage to 2 decimal places. So even though it's a whole number, we're going to have to put 0.00 so that we've got our 2 decimal places. And that's the end of the non-calculator section. And now we look at the calculator section. Question 9. Trevor wants to buy a new lorry for work. Trevor has to transport milk from the farms. he will need a lorry that is suitable to carry liquid. The liquid will be carried in a cylinder. He has seen 2 lorries for sale. Lorry 1 has a capacity of 536 feet cubed or cubic feet. Lorry 2 has the following dimensions. It's got a length of 19.35 feet and a diameter of 7.6 feet. And we're told that pi equals 3.14. Trevor wants to buy the larger lorry. Which should he buy? Show clearly how you decide. And then we've got to show you're working out and write your answer in the box below. Okay, so we've got 2 lorries. We're told that both of them will be carried in a cylinder. So if we're talking about a cylinder, let's think what that looks like. I mean, we've got a bit of a diagram or picture there, but we're going to have a sort of circle at one end, and then it's going to be this sort of shape at the other. Okay, the reason for drawing this is we can then use what we know about circles and these tankers to draw them on. So if we're thinking about lorry 2, I'm starting with lorry 2 because we already know the capacity. We can think of this as like the volume of lorry 1, but we're looking at, if we want the capacity of lorry 2, well, we know these dimensions. We know that the length, which is going to be this measurement here, is 19.35 feet. And we know the diameter, so this is the diameter all the way across, 7.6 feet. Right, now we want to know what the capacity is, or as I say, think of the volume. Well, if we want the volume is going to be the area of the circle, in other words, the area of this, times the length. Well, we already know what the length is, so we want to start off by working out the area of this circle here. Okay, well, I know that area of a circle is pi r squared. Right, well, we haven't got r. What we've got is the diameter, but I know that r is the diameter divided by 2, or in other words, 7.6 divided by 2, which if we use our calculator, we're going to get 7.6 divided by 2, which is 3.8. And that's going to be in feet. So that means that the area is going to be pi. Well, they've told us that pi is 3.14 times r squared. Well, we worked out that r is 3.8. So if it's squared, it means it's times itself. Okay. Well, we've already got this in here, so it doesn't matter which order we do it. We're going to have 3.18 times, 3.8 times another 3.8 times 3.14. And we get 45.3416. And that's area, so it's going to be in feet squared. Now, we want the volume. So the volume, or as I say, you can think of it, capacity. Usually when we're talking about volume, with the units would be millilitres or litres. So that's the only difference. But you can think of it as volume or capacity, that's fine. Well, it's going to be this answer up here. So the 45.3416 times the length, which is a 19.35. So we've already got this in here, multiplied by 19.35, and that gives us 877. And I am going to do, they haven't said how to round it. I'm going to round it to 2 decimal places. So 35, but this is a 9, so we're going to increase the 5 to 36, and that's going to be feet cubed. Okay, well, we know this capacity, and we know that this, actually let's write it down here, we know that 877.36 Well, that's more than 536. In fact, we could have rounded it to the nearest whole number because this is the nearest whole number. But still, we're going to get that lorry 2 is larger. Okay. So what we put down in our answer box down here is, again, we can put this here. We can put the 8. Let's round it to the nearest whole number. So we've got 877, which is greater than 536. So we want lorry 2. And question 10. Dahlia works 21 hours a week. Her employer says she will be able to increase her hours by 3 in a month's time. So she'll go from 21 hours to 24 hours. What would be the percentage increase in Dahlia's hours? Round to the nearest whole number. Right, percentage increase. So if we want the percentage increase, then we want the change, or the increase, which is 3, divided by whatever we're starting with, which is the 21. We want it as a percentage, so we're going to multiply it by 100. Okay. So we're going to have 3 divided by 21 equals times 100, and we get 14.28571. They've said round to the nearest whole number. Well, 14.2, 2 is less than 5, so it's going to be just 14%. Okay. Question 11. Terry has read that the span of a person's arm is correlated with their height. He decides to do an investigation to prove this theory. He measures the arm span and height of 10 people and records the information in a table. Here's the table. So for person 1, for example, their arm span is 121 centimetres and they are 125 centimetres tall. Okay, we've got this one. And they've asked us to draw a diagram on the next page to show the data supplied. Alright, so let's have a look at this page they've given us. We've just got a load of graph paper. Okay, now we're talking about correlation here. Okay, they've asked us to describe the correlation, but we're going to need to draw it first before we can describe it. So we've got to think about what kind of graph or picture we're going to be drawing here. Well, we've got 2 variables that we're looking at here. We've got arm span. So I'm going to put this along the bottom, and that's in centimetres. So let's think what this arm span is going to look like. Well, the smallest value we had, if I put this back on here, what's the small? They're in order. So small, oh no, they're not. But the smallest one is at the top. So we've got 121 centimetres. And what's the biggest number? 180. Okay, so we've got to think how we can fit this on here. Well, I might as well start at 120 centimetres. Okay, now we need to go up to 180. Let's think, in that case, maybe if we do it in tens, 130, 140, 150, 160, 170, 180. Yeah, that fits quite nicely. Remember, when you're planning out how to fit these on, you want to use up at least half of the graph paper. Okay, otherwise it might be too small, and if you do more than that, it won't all fit on. Right, so that's our arm span. Then we've got to think about going up the other side. Well, that was our height. And that's also in centimetres. So let's have a look at those measurements for the height again. So what's the smallest we've got? For height, we've got 125 centimetres, and the biggest is 175. So if we're going with sort of round numbers, nearest 10, we want to start at 120 and go up to 180 again. So it's going to be the same sort of measurements as before, but we're going up instead. So let's start with 120 again down here. And let's just think, if we fit this in, we could do 130, 140, 150, 160, 170, 180. Yeah, that's going to fit on the page nicely that way as well. Okay, so you know, I did my check before I wrote all the numbers on, because I don't know if I'm going to have to do any changes there. And while I've done that, I might as well just draw on a line for my X, and I'm going up to 180 because we want to go up at least as high as the biggest number we've got. And we're going to do that down at the bottom, or the X-axis as well. Okay, now all we need to do is to start plotting our values. So I'm not going to show this for all of them, but if we start with the first one, 121 centimeters arm span and 125 centimeters in height. So we had 121, so that's going to be here, and 125, so we're going to mark that on there with a cross, just like that. Now the next one, hopefully you've got these in front of you. If not, I'm going to read them out. We've got 140, which is here, and 136. So we can count 1, 2, 3, 4, 5, 6. I'm using these slightly fainter lines in the middle to tell me that where the 5s are. So that's how I was able to find this one quite quickly. Then we've got 132 arm span and 140 height. So it's going to be up here. Then we've got 150 and 150. Yeah. Then 156, 164. 56 up to 164. Just bring that down there. I'm always going across first because we've got the arm span as the first measurement. Then we've got 168 and 162. 168. 162 is there. 163 and 170. Just going off the page slightly. 180, 175. Which is up here. Yeah. 142, 140. And finally 162 and 159. 62 and 159. Right, okay, so we've plotted our values. What we haven't done is given it a title, so we can just say arm span against height. That's fine, that's describing what it's showing us. Okay, now we could just stop it there with the diagram, but we're talking about correlation, so I'm also going to draw on a line of best fit. Right, let's see if we can have all of our values, not quite all our values on the page at once, but close enough. So what I need for my line of best fit is a straight line that goes all the way through the data. I actually want a slightly longer ruler for this one, but I want it going through the data so it follows the overall pattern, and we've got roughly the same number of values above as below the line. Okay, now this happens to be going pretty much through that value, but it doesn't have to. If it does, that's okay. If it doesn't, that's okay. And I really want my line to be going from the smallest value up as far as the highest value. So let's just extend this up to here, but we don't want to go beyond because we don't have any information about the values beyond that. Okay, and then at the bottom it said describe the correlation the data displays. Well, as arm span increases, the height increases, so we can call that a positive correlation. The opposite to a positive correlation would be a negative correlation. So what that would mean is that as arm span increases, the height decreases, and that would be a downward sloping line instead. Okay. Okay, we've got question 12. Harry cycles on an indoor track. The record for distance travelled on an indoor track in an hour is 53.731 kilometres. Harry cycled 41.829 kilometres in 47.75 minutes. Harry thinks if he continued at the same speed, he could beat the record. Could Harry beat the record? Show why you think this. Show your working out and write your answer in the box below. All right, so he's cycled 41.829 kilometres in this time. We want to know how much he can do in an hour, so that's 60 minutes. So what we can start off by saying is, well, if he's done this 41.829 kilometres in 47.75 minutes, how much or how far would he travel in 1 minute? So let's divide it by 47.75. Okay, that's going to give us how far he can travel in 1 minute. So 41.829 divided by 47.75, which gives us 0.876. That's 1 minute. We want an hour, so we want to multiply this by 60, which gives us 52.56 kilometres. Okay, which is less than 53.731. So could Harry beat the record? No, it'll need to go a little bit quicker. Question 13. Dave is organising a charity event for his company. The company will increase the total raised by staff by 23.2%. Dave has collected £321.45, or £321.45p, which is 3/5 of the money promised by staff. How much will be raised in total? Okay, so he's raised, this is similar to the previous question, really, in terms of the way we're working it out. We're saying that 321.45 or £321.45p is 3/5. So we want to know what 1/5 is. So £321.45 divided by 3. 321.45 divided by 3. That gives us £107.15. That's 1/5. So all of it, the total they're going to get, is going to be 5/5. So multiply that by 5 to give us £535.75p. Okay, now we need to increase it by 23.2%. Now, if you like doing your compound interest, you could just multiply this by 1.232. So this is 23.2% as a decimal. Okay, and what I'm going to do is I'm going to show you how or what answer we get with this, which is 660.0, and I'm just going to do it 04 because it's money, so we're going to round to the nearest 2 decimal places. Okay, now some of you won't like doing the increase this way, so instead what we can do is say, well, we want 23.2%, so divided by 100 times 535.75. And this is going to give us, so this is the alternative method. So we'll do 23.2 divided by 100, multiply it by 535.75. So that means we're going to be increasing it by 124.29. And because it's money, I'm rounding to 2 decimal places. That's the increase, that's the 23.2%. So we'd need to add that to the original £535.75. Which is still going to give us £660.04p. Okay, you can see this way is slightly quicker because I've factored it all into just one calculation. But if you're more comfortable, work out the 23.2% and then add it onto the original. And this is our answer here. Question 14. An ice hockey league records the scores for the top 2 teams after 10 matches. So for Team A, we've got, let's move it up a little bit. We've got the goals scored per match. We've got the range. And we've got the mean. Okay, so the range should be the difference between the smallest and the largest value. And obviously the mean, adding all the values and dividing by how many we've got. For Team B, we've got the goals scored per match, but we haven't got the range or the mean yet. The coach of Team A says Team A scored more goals on average and were the most consistent goal scorers. Is the coach correct? Show how you know this. Right, well, we're talking about range and mean. We've got them for one team. We need to work it out for the second team. So as I said, the range is the biggest minus the smallest. So what's the biggest number we've got here? 51, 57, 59. And what's the smallest? 29. Yeah, that's the smallest. So we're going to have 59. Take away 29. You can use a calculator, but this is a nice one because our units are the same. So it's essentially 5 minus 2. So we've got 30. So for the mean, is the total divided by how many? Or the frequency. So let's add up all of the values. So 29 plus 51 plus 32 plus 43 plus another 32 plus 57 plus 59 plus 41 plus 33 and plus 40. And we get a total of 417. We know it's 10 matches, but I can check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 41.7. Okay, so we've got our values, so now we can see whether what he said is correct. So, the coach of Team A says Team A scored more goals on average and were the most consistent. So, we can say, yes, Team A scored more goals on average, and we want to refer to the value, so we can say 42.3 is greater than 41.7. Then it's talking about consistency. So more consistent, really, if you're more consistent, you want a smaller range. You want your values to be closer together. Well, actually, Team A's got a bigger range. So we can say, yes, they scored more goals on average, but, I'll underline, but Team B were more consistent as their range is or was smaller. So we can say that 30 is less than 42. Question 15. Sonia works in a call centre. She wants to calculate the average length of a call. She records the following information. So there were 40 calls that were between 0 and 2 minutes, 32 calls that were between 3 and 5 minutes, 30 calls that were between 6 and 8 minutes, 25 between 9 and 11 minutes, and 20 calls between 12 and 14. Estimate the mean length of a call. Right, now usually estimating is talking about rounding. With these types of questions, what estimating is doing is saying, well, we don't know how long these calls actually took. We just know that for each of these ranges, so for example this first one, we know that 40 calls were somewhere between 0 minutes and 2 minutes. They all could have been 0, they all could have been 2, some of them could have been 1 minute, some could have been 1.5. So what we're going to do with these, and this is our estimating bit, is say, well, let's just assume that all the calls in this range, or all the ranges, happened right in the middle. So halfway between 0 and 2 is going to be 1. Halfway between 3 and 5 is going to be 4. Now you can do it visually looking at them, or if you want to be 100% sure, so for example between 6 and 8, I know it's 7, but what you can do is say, well, let's do 6 plus 8 and divide it by 2. That gives me the midpoint, 7. So halfway between 9 and 11 is 10, and between 12 and 14 is 13. Okay, so we're going to kind of ignore this now, because we're not using the ranges. Now we're saying, well, actually, we're just going to say that there was 40 calls were 1 minute, 32 calls were 4 minutes, 30 calls were 7 minutes, and so on. So we're going to want another column, which is the frequency times the midpoint. Because we're saying, well, actually, how long were these calls in total? So if there were 40 calls that were 1 minute, well, 40 times 1 is going to be 40. And we're going to multiply all of these. So 32 times 4 is 128. We had 30 calls that were 7 minutes long, so that's 210. 25 calls that were 10 minutes, 250. And 20 calls that were 13 minutes, that's 260. So how long were the calls in total? Well, 40 plus 128 plus 210 plus 250 plus 260. So in total, all of the calls were 888 minutes. Now, we know that the mean is the total divided by the frequency, or how many. So in this case, the total is 188. The frequency, well, that's how many calls there were in total. So we're going to need to add these all together as well. So 40 plus 32 plus 30 plus 25 plus 20 means there are 147 calls. So 888, let's put that in my memory. 888 divided by the memory is 6.04 to 2 decimal places, or we can call this 6 minutes to the nearest whole number. Okay, question 16. Tyler is driving from London to Plymouth. Tyler travels at an average speed of 40 miles per hour, covering 32.1 miles to the gallon. So 1 gallon of petrol allows him to do 32.1 miles. Petrol at his local petrol station is currently 128.5p per litre. Notice this is in pence. Okay, 128.5p. Okay, then we've got a mileage chart here. So we've got the distances from all of these places to all of these places. And we're also told that 3.785 litres are equal to 1 gallon. Okay. Now the actual question is, how much will the petrol cost? And how long will it take to get to Plymouth in hours and minutes? Right. So how much will it cost? Well, actually, I'm going to do the how long will it take first of all, because I think that's going to be a little bit simpler, but it probably doesn't matter which order you do it. So where is he driving from? He's driving from London to Plymouth. So we'll find London on here, and we'll find Plymouth. And we can use, if we draw lines across from London and a line down from Plymouth, then where they cross is what we want. Okay, so we've got London to Plymouth is 214 miles. Okay. Now, I started London, went to Plymouth. We could do it this way if we started up at London here and went down and then found Plymouth and read across, we'd still get the same answer. So it doesn't matter which way you do it on the chart. Right, so we've got 214 miles, and we know that he's travelling at an average speed of 40 miles per hour. So 214 divided by 40 miles per hour is going to tell us how many hours it takes him. So 214, let's put that there, divided by 40 gives us 5.35 hours. Okay. Now, that is not 5 hours and 35 minutes. This is all in decimals at the moment. Okay, so we do know that we've got 5 hours. So we put 5 hours. But the minutes we're not sure about. But if it's 0.35 of an hour, I know there's 60 minutes in an hour. So if we do 0.35 times 60, that's 21 minutes. So it's 5 hours, 21 minutes. Okay. So this is the how long. Let's do a little error. So we've answered that. Sorry, you couldn't see that bit when I was working it out, but we've got the calculation just down there. So now we want to think about, well, how much does it cost? Okay, well, again, let's think about how far it is. So we've got 214 miles, and it covers 32.1 miles to the gallon. So we want to know how many gallons, so we're going to divide it by 32.1. So 214 divided by 32.1 gives us 6.666 recurring. That's gallons. Okay. We want to turn that into litres because the cost we've got is per litre. So we're going to multiply that by 3.785. Okay, because we know that there's, if we look back up here, we know we've got 3.785 litres to 1 gallon. So I can keep this answer in here, the 6.666 multiplied by 3.785, and we get 25 point, I'm going to round this to 2 decimal places now, so 25.23. So what's that going to be? That's going to be litres. Now, we know that the cost is 128.5p per litre. So if we multiply these two together, times 128.5, we get 3242.48. Now that's p, so that's just pence. If we want to turn it into pounds, well, there's 100 p in £1, so we need to divide it by 100, which is going to give us 32 point, and we want 2 decimal places because it's money, so £32 and 42 pence. Okay. So let's underline this one, and this is the petrol cost. So we've got our 2 answers. So 6 marks, quite a lot going on there. Okay, question 17. Alex wants to invest £14,000 in a savings account for 2 years. He finds information about 2 savings accounts. Both accounts pay interest at the end of each year. So we've got Saver 1 with 3% each year, and Saver 2, 5.3% for the first year and 0.9% for each extra year. Well, in this case, if it's for 2 years, it's going to be 5.3% for 1 year and then 0.9% for the second year. Alex thinks he will earn more interest at the end of 2 years with Saver 1. Is Alex correct? Okay, well, let's have a look at it. So if we work out the value of Saver 1 at the end of 2 years, well, we're starting with £14,000. We've got 3% for the first year, so multiplying it 1.03. So the 1 represents that it's still 100%. We're still going to have 100%, and we're going to add 3% on. So this 1.03 represents 103% of the original. That'll give us the value after the first year. So after the second year, we're going to have another 3%. So 14,000 times 1.03, and then times another 1.03, okay, which is £14,852.60. That's the total value. They're asking us about the interest earned. So if we want the interest, we need to take off the original amount. So we can have that the interest, just the extra bit, is going to be £852.60. Now for Saver 2, we're still starting with £14,000. In that first year, we've got 5.3%. So let me show you how I'm going to turn this into a decimal. So I'm going to say 5.3 divided by 100. So 5.3 divided by 100 gives me 0.053. Sorry, 0.53. And then we're going to add on 1 to give us 1.053. Okay, so this represents 105.3%. That's for the first year. For the second year, we can do something similar. So if I show you on here, we'd have this 0.9 divided by 100, then add on 1. So we've got 1.009. Okay. You might want to rewind and have a look at the video and check you're happy with that. So we've got 14,000 times the 105.3%, and then plus the 0.9%, which gives us a total of 14,874.6. To 2 decimal places, we're going to round up to 68. Then if we subtract the 14,000 to tell us just what the interest amount is, we've got 874.68. Okay. Well, we've got £852.60 is less than 874.68. So, no. Saver 2 will earn more interest. Question 18. Zeb received a student loan of £12,780 last year. Her student accommodation cost £142 per week for 30 weeks. What fraction of her student loan was used to pay for student accommodation? Write the fraction in its simplest form. Right, so how much was the student accommodation? Well, it was £142 for 30 weeks. 142 times 30, which gives us £4,260. We want that 4260 as a fraction of the total cost, which was a 12,780. Right, so we want to simplify this as far as possible, okay? So you get 1 mark if you got this far. Well, the first thing I can do is cancel off the zeros. So we've got 426 divided by 1278. Now, you can just keep trying to see what numbers go into both of these. See if you can find some common what's it, common factors, that's the word, couldn't remember. We could say, well, they're both even, so I know I can divide them by 2, but there's another little trick that you can do, and that's if you add up the digits, you can sort of find out whether 3 would go into them as well. But actually, let's divide it by 2. Okay, they're both even, so we're going to do 426 divided by 2, which is 213, and 1278 divided by 2 is 639. Okay, and then we can say, well, can we go any smaller? Well, they're both odd now. Well, let's see whether 3 goes into both of them. So 213 divided by 3, 71. And 639 divided by 3, yep, 213. So there's a little bit of trial and error now, just to see if we can keep going. Well, what other numbers might go into 71? 3 doesn't go in, so that's not going to help me. It's an odd number, so I know it's going to have to be another odd number divided by 7. No, it doesn't help. What about 13? I'm just trying different odd numbers here. No. What else could we try? So 17. No. Divided by. Why isn't this working? Well, a nice one we can say. Well, if we're not finding numbers that go into both, what about if 71 actually goes into 213? So let's try 213 divided by 71. Yeah, so we're going to divide both of them by 71. Now, this is very difficult to see. It's not something you just spot, oh, yeah, I know that 213 is in the 71 times table. You're not going to spot that. So that's why you do have to do a little bit of trial and error. But as I say, if nothing else is working, think, well, what about using the number itself? So 71 goes into 71 once. And we saw, well, 71 goes into 213 3 times. Yeah, if you've got a scientific calculator, you could just do 71 divided by 213, and it's going to give you a nice, easy 1/3 for you instead. So that's the benefit of using a scientific calculator for these types of questions. So there's our simplest form. Okay. Question 19. Marcus hires a car for 8 days for a work trip. He travels 378 miles. The car hire company used the following formula to calculate the total hire cost. So we've got hire cost equals 27D plus 0.2 M, where D is the number of days and M is the miles travelled. Marcus can claim £300 in expenses for car hire. Will this cover the cost of the car hire? Right, so let's see. So the hire cost, 27D. So that means 27 times D. D is the number of days, so it's going to be 27 times 8. Then we're going to add on 0.2 times the number of miles. The number of miles is 378. So we've got to remember our bid mass rules here. We're going to have to do our multiplications before the addition. So 27 times 8, 216. And 0.2 times 378 is 75.6. So if we add these together, we get 291.6. This is money, so we're going to make it £291.60p. Well, that is less than £300. So yes, we'll cover the cost. Okay. Question 20. We've got 92, then brackets, 45 divided by 5 times 3 plus 32. Right, so testing our bid mass rules here. When you've got a number next to a letter or next to some brackets, there's a hidden multiply sign in there. Okay. but we need to do the brackets first. Okay, so let's do this bit of the brackets. So 45 divided by 5 is 9. Then multiplied by 3 is 27. So in other words, let's write it down here. We've still got the 92 because we've not done anything with that yet. We found out that everything in the brackets is equal to 27. Then we're going to add on a 32. Right, so what's the next bit we do? Well, multiply or add. We're going to do the multiply first. So 27 times 92 is 2,484. Then we'll add on the 32. I'm writing down every step. You can miss out the odd step if you want to. When I say miss it out, you don't have to write it down, but you will still need to do it. And there's our final answer. Okay. And the last question for this paper, it's quite a long paper. We've got question 21. Rona is a member of a fishing club. She records the weights of the fish she catches in one day. Okay, so we've got 5 different fish here. The heaviest fish caught by a club member was 10.8 pounds, where 1 pound equals 0.454 kilograms. What's the percentage difference between the median weight of fish Rona caught and the heaviest fish caught by a fishing club member? Right, so we're talking about median. So that's the middle number. So we're going to need to order these. You could convert them first or do the median first, but I'm going to do the median first because then we don't have to do so many conversions. So let's look at them from smallest to largest. Well, this is the smallest, 43. Next smallest is this one. Then this one. Then this one. Then this one. Now, what we can do is then write them all out in order. So the smallest one is 4356. Then we've got 4803. Then 4851. Then 4913. And finally 4985. Then for the median, we cross off the smallest and the biggest and the next one. But what we could have done was said, well, if there's 5 values, I know the middle value is going to be the third one. So we could just go straight for this. Okay. So they want the percentage difference between the median weight and the heaviest fish. Well, the heaviest fish by a club member, we've got it in pounds. So if 1 pound is 0.454 kilograms, what we can actually do, it might be easier to turn this into grams or kilograms rather than turning the grams into pounds. You can do it either way. So what I'm going to do is say, well, if this is 0.454 kilograms, I know that that is the same as 454 grams. So multiply this by 1,000 to get it in grams. So if we want to turn this into grams, we multiply this by 454. So 10.8 times 454, which gives us 4,903.2 grams. Okay, now we know the median is this value. So the difference is going to be the bigger number, which is the 4903.2, minus the smaller number, the 4851. Okay, which gives a difference of 52.2 grams. Now, we want the percentage difference, and it's between the median weight of the fish caught by Rona and the heaviest fish. So it's this heaviest, where are we? Yeah, so if it's the percentage difference, we're going to want percentage difference. Well, the actual difference is a 52.2. We need to divide it by the median weight, 4851. And because it's a percentage, we're then going to multiply that by 100. Okay, so 52.2 divided by 4851, multiplied by 100. So this is our percentage difference. So it's 1.07606%. Well, let's round this. I'm going to round it to 2 decimal places. So 0.7. We've got a 6, so we've got to round it up. So it's going to be 1.08%. And that's our final answer. So just over 1% difference. Okay. You could have done it slightly differently in that you could have done the 4903.2 divided by 4851. Let me just show you that. So if we did 4903.2 divided by 4851, that gives you the sort of the percentage difference, but includes the 100%. So you then need to take off the 1 and multiply it by 100, but you still get the same answer that we got before. It's just a slightly different way of thinking of it. Okay, so this was a new exam board for me. I don't know if it was a new exam board for you, but hopefully you found it interesting, whether you're sitting the exam with these people or not. It's always nice to try these different ones because it just means that you're much more prepared in case you get questions worded in a slightly different way. Okay, so please like the video if you liked it, give me a comment, subscribe to the channel, make sure your notifications are on so you get updates, and I look forward to seeing you again soon. Thank you. Bye.